Hi, Kellen. What I'm going to do is I'm going to go through the basics for you of scientific notation and then go over some problems that are in the book with you on specific pages. So, for starters, scientific notation is just a method of writing really big or really small numbers abbreviated so they can fit in a calculator. So, say I have this number. This is a really big number that would not fit in a calculator. And that poses a problem for scientists. So, what they do is they write this in what's called scientific notation. This is the same thing as 2 times this ginormous number. And this large number can be written as 10 and an exponent. So what I'm going to do is I'm going to count the zeros. There's 3, 6, 9, 10, 11 zeros. So this is 2 times 10 to the 11th power. And without writing this out, I could just count backwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's the number of decimal places that you move the decimal so that our greatest place value is the ones place value. So a number like this, and I'm not going to write all big numbers here in these examples, like 24,000. We can write that simple number in scientific notation. Remember, we have to move the decimal so that our highest place value is the ones place. So I'm going to move my decimal 4 places over, and that tells me my exponent. Oh, I forgot the 4. 2.4 times 10 to the 4th power. I'm going to do one more. 352,000. So again, we want to make sure we make a number that is between 1 and 10. So the highest place value is the ones place. So I'm going to move the decimal from here to here. And I count the place values. And I get 3.52 times 10 to the 5th power. So that's for really big numbers. So if I plug a really big number into my calculator, like if I plug in the first one we did, 2 times 10 to the 11th power, the calculator writes it with an E, and that E means exponent. So this abbreviation, even further abbreviated, is called calculator notation. It's not scientific notation unless you write it with the 10 as your base and the 11 as a power. But just in case you see that in your calculator as you're doing problems from the book. Okay, so let's practice some from the book. Now, these are all large numbers. I'll go over small numbers with you after we do some from the book. So I'm on page 644, and 644 has practice going between scientific notation and standard form. Standard form is just when it's a regular number. So for this one, I have 3.34 times 10 to the 22nd. That means I'm going to move this decimal 22 times to make a really big number. So I have to count these as part of my move. So I'm not adding 22 zeros. I'm only going to add 20 because I have to count these two place values. So 334 and then 20 zeros. Now, I would always tell kids to, put the commas in so we can actually check and see if we have the same answer. But anyway, Same thing here. This is 2.5 times 10 to the 13th. That means I'm going to move the decimal 13 places. One place is taken up with this move. So I don't add 13 zeros, I add 12. There we go. Okay, and then these second two problems is rewriting it in scientific notation. So we decide where we want the decimal. We want the decimal between the 5 and the 8. And then we count. How many places is that? 3, 6, 9, 12. So it's 5.88 times 10 to the 12th power. Same thing here. 1, 2, 3, 4, 5. Between the 1 and the 8, remember the 1's place is always the largest place, times 10 to the 5th. Okay, so in the second part of this page, they want us to determine if this is actually in scientific notation, and if it's not, to write it in scientific notation. So we look for two things. Is this number between 1 and 10? And then is it a power of 10? So this one is in scientific notation. The population of Pitcairn Island is not in scientific notation because the number is not between 1 and 10. To do so, we would have to move the decimal here. So when we rewrite this, it's going to be 6.7 times 10 to the first power because I moved my decimal 1. So Australia, the population, is not written in scientific notation because this number is not between 1 and 10. So I have to move the decimal an additional place. And when I do that, I have to increase the exponent to account for that additional place. And then you can see the population of the United States is in scientific notation because this number is between 1 and 10. All right, so that was kind of a rundown on large numbers. I'm going to stop this video and then I'll do a separate one on really small numbers. And then later on, maybe this week, I'll do one on operations with scientific notation and comparing numbers. All right, I hope this helps. But if it doesn't, you can email me and we can Zoom again.